This is pages 50 and 51 in your math journal. Okay, this is the one that I told you you're going to paste those graphs that I gave you in class in. There should be one on the far left side and then one on the far right side. They look exactly alike, but we're going to use them for different teaching parts. So, this one I want you to label 50. We're going to call it the coordinate plane. Alright, first of all, we got to get to know the different parts of a coordinate plane. You guys are actually fairly used to graphing in this section. So if you've ever made the L-shaped graphs, you're familiar with this, but what we're doing today is we're extending your knowledge to the negative parts of the graph. Alright, the coordinate plane is made up of two number lines. We have the horizontal number line, or axis. It's called the x-axis, so we're going to give, I want you to write x-axis. And then the only thing I want you to write is the horizontal one, just so we're just going to write horizontal. So this right here is our x-axis. Okay, the second one, the vertical one, is called our y-axis. And for that one, let's just write vertical. And it would be this one. So we have our x-axis and a y-axis. When they're laid over top of each other, now we get what we call the coordinate plane. Okay, the most important part of the coordinate plane for us is the origin. The origin is where the x and y axis cross. Okay, in parentheses, I want you to write parenthesis, and then write a 0, comma, 0, and another parenthesis. Right, the origin is found right here. Okay, now notice here that the axes break it into 1, 2, 3, 4 sections. These are called quadrants. Okay, and quadrants are the 4 sections of a coordinate plane. Okay, there are 4 of them, and they're labeled with Roman numerals. So there's quadrant 1. Okay, I want you to be careful as you're writing this because we're going to be writing some stuff about this. So we have quadrant 1, and then I want you to draw a line like that. We have quadrant 2, so 2 eyes, another line. This has to be super neat, so be sure you're writing your neatest, and it needs to look a lot like mine or you're going to run out of space. We have quadrant 3. And we have quadrant 4. Now 4 is different. It's I and then a V. Okay, so up here, quadrant 1 is the one you are used to graphing in. Okay, the x is positive. So I want you to write right here, x is positive. Notice here on my number line, these numbers are positive. So my x values are positive. The y values are also positive. Okay, notice there's a third line. We'll come back to that in a minute. Okay, right here I want you to write quadrant 1. Okay, and it kind of makes a C. So it goes 1, and then 2 would be this one. Okay, in quadrant 2, our x values are negative. So our x values are negative, but the y values are positive. Okay, this is quadrant 2. Okay, this one right here is quadrant 3. Our x values are negative, but so are our y values here. So let's write 3. Okay, and then this would be quadrant 4. Notice how they make a C. That's just one way to remember. Everybody remembers quadrant 1, but then they can't remember what order it goes in. So 1, 2, 3, 4, it kind of draws a C. So in quadrant 4, our x values are positive, but our y values are negative. So next thing, notice they still have a line here. We're going to come back and fill this in. But next right here, I want you to write ordered pair. Okay, an ordered pair is basically the address of a point on the coordinate plane. Okay, it's always written with parentheses. The x value is always first. So we always are looking at the positive, or at the x, or the horizontal part. Y is always written second. Okay, now up here, we're going to write what this would look like as an ordered pair. So I want you to write a parentheses. Now since x is positive, we're going to have a positive number here, comma. Y is positive, we're going to have a positive number in this spot. Okay, any ordered pair in this area, your x will be negative, your y will be positive. An ordered pair in this quadrant, your x will be negative and your y will be negative. And here, your x will be positive, but your y will be negative. Okay. Now, how do we read coordinates on the coordinate plane? Okay, that's what this graph's going to be for. So I want you to write A, and we're going to go find its coordinates from this graph. So find A, right there. Now A's coordinates are ordered pair. We always look horizontal first, and it's always from the origin. So it's distance from the origin is really what an ordered pair is. So I call it the address because you guys are used to finding addresses like in town. Well, this is just an address of this point. So it is 2 to the right of the origin. So my horizontal, it's positive. I went positive 2. And then 1, 2, 3, 4, 5, 6, 7. 7 on the y-axis, or up 7. Okay, let's do B. Find B. Now, horizontal is always first. So always be prepared to go left to right before you go up or down. So B is 4 units to the left, -4. See how that lines up with -4? But that's not the only thing. -4, anything on this line right here could be -4. So we have to have a second part to tell me where to be. B is also 6 units up. So it would be positive 6. Now look how this is negative and this is positive. It is in the second quadrant. See? Negative, positive. Okay, let's do C. So C is located... Oh, we don't have a C on this one. All right, never mind about that. Let's find D. So there is no C on this one, so I'm just going to go over here and write D. Actually, we can create a C. I want you to plot any point you want and then label it C, and then you can write the coordinates of C. I'm moving on to D, because yours is going to be different depending on where you put it. So D, actually, I changed my mind. Go back. C, I want you to put C right here. Okay, so make sure your C is right there. Okay, on the x-axis, that would be negative 3. And then on the y-axis, how far did I go up? 0. So this is right on the axis. This one is actually not a part of a quadrant. It's actually on the x-axis, and you can see that. So in order to be part of a quadrant, it has to be inside this space. But if it's on the fence, it's on the axis, and it's actually not part of a quadrant. Okay, D, that would be negative 3 for my x. Negative 3 for my y. Notice it is in the third quadrant, so this would be quadrant 3. E, how far did we go left to right from the origin? 0. So this is 0, and then up 2. So E is 0, 2. And the last one, F, is 7 to the right. So that's a positive 7. And then down 1, 2, 3, 4, 5 at negative 5. So my y value is negative 5. Okay, that's all an ordered pair is. It's just the location of where you find that point. Okay, well now sometimes you're going to be asked to graph a point. So here, I want you to graph on this empty coordinate plane. Okay, so we're going to graph these points. I want you to graph, let's say H, and you're going to graph it at negative 2, 4. So go negative 2 on the x-axis, 1, 2 to the left, positive 4 on the right, or on the y, so that means up 1, 2, 3, 4. Put a dot right there. That would be point H. Okay, I. Let's graph the point 0, negative 6. So I'm going to go 0 on the x-axis, so that means I'm not going to move anywhere left or right of the origin. And then I'm going to go down because of the negative. 1, 2, 3, 4, 5, 6. Let's label that I. Okay, now let's do J. Okay, pay attention to what this one says. I want you to graph it at 1.5 and negative 3. Okay, halves aren't on here with tick marks. However, you can still find 1.5. Okay, this is positive, so I'm going to go positive 1 and half a unit over. So right halfway in there. But that's not where my point goes. That's just the x value. But now I need to go down 3 units in my y. So right here at 1.5, I'm going to go down 1, 2, 3, and I'm going to make a dot right there. See how it's halfway? There's 1.5 units away from 0. and 3 units down. So this would be J. Okay, one more. Let's do K. And I want you to put it at negative 2.5 and negative 0.5. Okay, so negative 2.5. Remember, always horizontal first. So 2.5 is the same as half. So I can find it right there. But then I also want to go down half a unit. So I'm going to go down half a unit. It's going to be right there. Okay, and we'll label that one K. So that's how you graph. So if you can read them, graphing them is no problem. It's just the other way. You have the address and you need to put it on the graph. Okay, now we're going over to page 51. Okay, so just the same page, but just the other side. Okay, go ahead and label this one 51. Okay, now we're going to be talking about reflections. Okay, so a reflection, we can kind of give this one the title of reflections. Okay, now these are reflections on the coordinate plane. I want you to think what you know about reflection. Where have you heard that word before? Most of you probably thought of a mirror. When you look at a mirror, it looks exactly like you except for it's flipped. Notice when you look in a mirror, like you can't read the words on your shirt because they're backwards. Okay, well that's what we're going to be working with here. So a reflection on the coordinate plane. So let's write reflection. So the reflection is a mirror image on the opposite side of a line. All right, over here, we're going to make a simple triangle. So I want you to put a point at 1, 1. We're going to label that A. Another at 1, 5. We're going to label that one B. And one more at 3, 2. And we're going to label that C. Go ahead and draw lines connecting those to show our rectangle. Okay, so if we have this and we want to reflect it, we first have to have a line to reflect it across. So basically our line of reflection. So next definition I want is line of reflection. Okay, and the line of reflection is, well, it kind of seems obvious, the line you reflect over. So line and image is reflected over. Okay, and for you guys, we're just going to be doing basic reflection. We're just going to be talking about over the X or Y axis. So we are going to reflect this over the Y axis. So find the Y axis. And now I'm going to use that line to create my reflection. So what happens is this is kind of like my mirror line. And it's going to be kind of like a line of symmetry here. So if A is right here, notice how it's 1 unit away from the line I'm reflecting it from. So then I'm going to draw A over here, but now this is not the original A. So when reflecting or doing any kind of translation, we actually write a little tick mark next to it. So A would be the original. So how we know that the new one is the reflection, we put a little tick mark by it. That right there. It's called A prime. Okay, and that is the image, or after it's been reflected. So since I plotted this point here, it's not the original, so I'm going to write A, and then I'm going to put a little tick mark by it, A prime. That lets me know that that's my reflection. Okay, my other points. B up here is 1 unit away, so I'm going to go straight across from there, and it's going to be 1 unit away. This would be B prime. And then right here, C is 1, 2, 3 units away. So 1, 2, 3 units away. This would be C prime. Now, you can see my mirror image of that original figure. See how it's the same exact distance away from my line of reflection. Now, sometimes we can reflect an image. So first, we reflected over the y-axis. Now we're going to reflect this image, and we're going to reflect it over the x-axis. So how do you know if it's the second one? Well, you put 2 tick marks instead of just 1. So looking at this, if I reflect it across the x-axis, it's 1 unit away. So if I'm going across the x-axis, I'm comparing everything to the x-axis. So this is 1 unit away. I'm going to go 1 unit away again. This would be A, and then I'm going to put 2 little tick marks, A prime prime. That's how you'd say it. This one is 1, 2, 3, 4, 5 units away. So I'm going to go 1, 2, 3, 4, 5 units away in the opposite direction. This will be B prime prime. It's the second reflection because I'm reflecting the reflection. Okay, the last one I have is 1, 2 units away from the x-axis. So from the x-axis, I'm going to go 2 units the opposite direction. That would be C prime prime. Now, if I connect it, you can see my mirror image of my original reflection. Okay, so that's how reflections work. We're going to practice just a few of them. Notice this is just like the other one you had a minute ago, only now what we're going to be doing is we're going to be reflecting. I'll tell you which ones to reflect across which axis, and then you're going to write their new coordinates. So, skip one line, and you're going to reflect these ones across the x-axis. We are going to reflect B, and we're going to reflect F. So B's original coordinates, let's look at B's original coordinates. B's original coordinates were -4, 6. Okay, our reflection, we're going to reflect it across the x-axis. Remember, you got to pick the right one. X-axis, so I need this to be my line of reflection. So if it's 1, 2, 3, 4, 5, 6 units away from the x-axis, I need to be 6 in the opposite direction. 1, 2, 3, 4, 5, 6. Put a dot there, and I want you to write B prime. There's our reflection across the x-axis. Now what are its coordinates? -4, -6. Oh, that's interesting. Look at that. If I reflect across the x-axis, notice how my coordinates here are just opposite of each other. Well, that makes sense because it's on the opposite side of the x-axis. Well, my vertical part changed. So let's look at F. My original coordinates for F are positive 7, negative 5. So if I reflect that across the x-axis, I'm 1, 2, 3, 4, 5 units down. So the opposite would be 5 units up. 1, 2, 3, 4, 5 units up. Put a dot there, F prime. So F prime is located at positive 7, positive 5. Notice again, my y value, my x value did not change, but my y value did. It's now positive when it was negative. So what do you think is going to happen when I reflect things across the x-axis? Well, let's see. Okay, so we're going to reflect these points. So reflect across y-axis. Okay, we're going to do point D and point E. Okay, let's find their original coordinates. So point D is negative 3, negative 3. So if I reflect my new point, so D prime, across the y-axis this time. If it was across the x, it would be over here. If I'm reflecting across the y-axis, this is the y-axis, so I'm comparing everything to there. It's 1, 2, 3 units away to the left, so I'm going to go 1, 2, 3 units to the right. D prime will be located right there. So by reflecting it across the y-axis, my new coordinates are positive 1, 2, 3 for the x, negative 3 for my y. So look, when we reflect across the y-axis, the y value stayed the same because it didn't move up or down, but it did move left and right. So let's look at E. Right here, it's at 0 on the x-axis. It didn't move left or right. And positive 2. So reflect across the y-axis. How far is E from the y-axis? 0 units. So my reflection, or E prime, is going to be also 0 units from the y-axis. So we're going to move it 0 units from the y-axis, and oh, guess what? E prime is the exact same as E. That's because it was on the axis. Now the reason for this, because it's on that axis, it doesn't have a distance from y, so it can't really move. Okay, that's how reflections work. And sometimes you'll be asked to reflect and then reflect again. And you can do that. Okay, one last little part is we're going to be talking about distance between points. So skip one line, I want you to write distance between points. Okay, if they form a straight line, it's easy to tell the distance. So we're going to plot these 2 points. We're going to plot A and B. A is going to be at negative 4, 3. B is going to be, actually we're going to do 4 points. B is going to be at negative 4, negative 2. C is going to be at 5, 3. And D is going to be at 7, negative 2. Okay, so let's plot those points. A, negative 4, positive 3. B, negative 4, negative 2. C is going to be at 5, 3. Oh, I meant to write C there, not 3. And D is going to be at, oh, I put 7. Yeah, we can graph 7. 7, negative 2. That would be D. All right. If I'm looking at these, if they're a straight line away, how can I tell that they're a straight line away? We'll see how this has negative 4 and negative 4. Notice how A and B are a straight line away. Well, once I graph them, I can just count how far apart they are. So if I want to know how far it is from so if I were to draw a line from A to B, how far are they from each other? 1, 2, 3, 4, 5 units. Okay, if I were looking at B and D, so how far is it from B to D? Well, if this is negative 4, that's 4 units to 0. And then if this is 7, this is 7 units. So this would be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. So if they form a straight line, it's easy to tell. Now, you are not going to be asked to find like B to C. That's 8th grade math, and you don't have to worry about that right now. But you might have to be asked how far it is from one point to another. If you question it, graph it, and then see how far apart they are. If it's a straight line, all you have to do is count it. I could count these ones, I can count these ones, and I can count those ones. So it's not too hard. You just have to graph them and count how far apart they are. Okay, that'll be the end of your notes.